Hello and welcome to this video. So we are going to proceed from where we left during the last video, and that is question number 18. So let's get straight away to question number 18. So question number 18 states that a line L1 passes through the points 3, 3 and 5, 7. Find the equation of L1 in the form y is equal to mx plus c, where m and c are constants. Okay, so let me draw a simple Cartesian plane here. Okay, that way. Okay, so let's say this is point, or this is 3. Okay, this is the x-axis and this is the y-axis. At 3 we have 5. Let's say 5 is somewhere there. Then we have 3 and we have, let's say, 7. Okay, so we have point 3, 3. This line passes through the points 3, 3 and 5, 7. Let's say it's that point. Okay, so let me sketch this line. Okay, that way, just a sketch. Okay, so we are told that this line passes through the points 3, 3 and 5, 7. Okay, so we need to find the equation of this line. But before finding the equation, we need to get the gradient of this line. The gradient, which we are going to use to get the equation of this line. So how do we get the gradient of a line? So we get the gradient by dividing the change in y by the change in x. So what do I mean by the change in y and the change in x? So when you look at this equation, or this line rather, we have point 3, 3. So 3 is the coordinate of x and the coordinate of y. The same case here, we have 5, the coordinate of x, and 7 is the coordinate of y. So let me start with y. Okay, at this point, y is 3. Okay, y is 3. Then we are moving upwards to where y is 7. Okay, so we are moving upwards from here where y is 3. Okay, we're moving upwards up to where 5 or y is 7. So in other words, y is changing from 3 to 7. So what's that change? That is a change of 4. Okay, from 3 to 7. So the change in y for this case is 4. What about the change in x? At this point, the coordinate of x is 3. And then we are moving this way to where x is 5. So in other words, x is changing by 2 units. Okay, so the gradient is going to be equal to 4 divided by 2, which is 2. Likewise, you don't have to draw a Cartesian plane if you want to save time. So what you need to do is to get the coordinates. So the first one was 3, 3, and the other one is 5, 7. So what do you do with these coordinates? As long as you know that x, or 3 is the coordinate of x, and then the coordinate of y is 3. For this case, 5 is the coordinate of x, and 7 is the coordinate of y. So you just need to you can get the gradient directly using this formula, change in y over change in x. You just need to look at 3 and 7. That is the change in y. So, and then you can say 7 minus 3. Okay, it's moving from 3 to 7. So 7 minus 3, that is the change in y, and then we divide it by the change in x, which is from 3 to 5. So 5 minus 3. So we have 4 and we have 2. 4 divided by 2 is 2. So we now have the gradient of this line. So we are going to use this gradient to get the equation of this line. And how do we go about it? So what we do is that on the same line that is L1, we're going to get another point. We're going to get another point on this line, and we're going to call it xy. Just any point on that line. And then what we try to do is that we try to get the gradient of this line using this point xy and any other point that you already know of. You have 5, 7 and you have 3, 3. So we have point xy and we have point, you can take either 3, 3 or 5, 7. Let me go with 3, 3. And we now know that the gradient is 2 of this line. So we are going to try and find the gradient using these points, and then we can now equate it to 2. So let's try to get the gradient. So let's start with the change in y. So we have 3 minus y. As we said, we subtract y from 3 or 3 from y, whichever you like, as long as if you subtract y from 3, then when you go to the change in x, you should subtract x from 3. Don't interchange them, okay? If you stick to 3 minus y, for the change in x, also let it be 3 minus x. So it's going to be 3 minus x. And then now we equate it to the gradient, which is 2. Okay, we are told that this equation should be in the form y is equal to mx plus c. So our intention here is to make this equation resemble this form. So how do we do that? At this point, we are going to cross multiply. We're going to cross multiply. So it's going to be 3 minus y. So you multiply this by this and this by this. So it's going to be 3 minus y is equal to 2 multiplied by 3 minus x. And this is going to be 3 minus y is equal to 6 minus 2x. Okay, still our equation is not in this form. So we need to move this 3 to this other side. So if we subtract both sides by 3, or we subtract 3 on both sides, we're going to have negative y is equal to 3 minus 2x. Remember, we need y on this side, not negative y. So we need to get rid of this negative, and if we divide through by negative 1, or we multiply through by negative 1, we will have gotten rid of that negative sign. Okay, so this is going to be y is equal to negative 3 plus 2x. So we are still a step further. Okay, when you look at this equation and this form, you can see that this constant c should come at the end. Okay, and mx is the one that should come in front of the constant. So we need to rearrange this equation so that it looks like this form, or it resembles that format, that is y is equal to mx plus c. So using that format, we're going to have y is equal to 2x minus 3. So this comes here and this comes here. So we now have the equation of that line, which is y is equal to 2x minus 3. Then we can now proceed to part B of the same question. So part B states that another line L2 is perpendicular to L1. Okay, so this was line L1. Then we are told that there's another line that is perpendicular to L1, and that line passes through points negative 2, 3. So we have a line L2. This line is perpendicular to L1, and then it also passes through the points negative 2, 3. So the question is, find the equation of L2. Find the equation of L2. Okay, there's a concept that I want us to get here. So if two lines are perpendicular, the product of their gradients is equal to negative 1. Okay? If two lines are perpendicular, like for this case, these two lines we are told that they are perpendicular. So if two lines are perpendicular, the product of their gradients is equal to negative 1. So we have line L1. We already know that the gradient of line L1 is 2. But we don't know the gradient of L2. Remember, the question requires us to get the equation of L2. But to get the equation of L2, we need first the gradient of L2, which is not given. But from this relationship that I'm saying here, that the product of two perpendicular lines, or if two lines are perpendicular to each other, the product of their gradients is -1. So for L2, we don't know the gradient, we can call it M. So if we multiply the gradient of line 1 by the gradient of line 2, which is M, that we don't know it, we're supposed to get -1. So this is the same as 2M is equal to -1. So if we divide through by 2, M becomes -1/2. So M now is the gradient of L2. Okay, so we have now the gradient of L2, it is -1/2. And we have one point that we know it's -2, 3. So as we said, we can get the equation of a line using the gradients and one point. Okay, what we need to do is to identify another point xy. Okay, any other point on that line. And then we try to get the gradient of this line using this point that we don't know and this point that we already know. And then we can now equate it to the gradient. So this is going to be 3 minus y, that is the change in y, divided by -2 minus x, that is the change in x. This should give us the gradient, which is -1/2. Okay, -1/2. So this negative sign, you can either decide it to be at the top or at the bottom, at the numerator or at the denominator. But don't put it on both sides, because when you put it at the top and also at the bottom, it will turn into a positive. But you can either decide it to be at the top or at the bottom. So let mine remain at the numerator. Okay. So when we cross multiply this, it's going to be 2 multiplied by 3 minus y is equal to -1 multiplied by -2 minus x. So this is going to be 6 minus 2y is equal to, this is going to be -1 times -2 is +2. And then this one is also going to be positive x. So we now need to write this equation in the form y is equal to mx plus c. Though we are not told to write it in this form, it is always good to write an equation of a line in this form. So let's try to write it in this form. So we need y on this side. So this 6, we are going to move it to this other side. So we can subtract 6 on both sides, so that we have -2y is equal to -4 plus x. And then we can divide through by -2 by -2, so that on this side we will have y is equal to 2 minus 1/2 x. Okay, still it doesn't resemble this format. We need to rearrange it this way. Y is equal to -1/2 x plus 2. And that is the equation of line L2. That is the equation of line L2. So let's move on to the second part of part B. So we are told to get the x-intercept of line L2. The x-intercept of line L2. So what do we mean by the x-intercept of a line? The x-intercept is the point. Okay, so let me draw a simple Cartesian plane here. So this is the x-axis and this is the y-axis. So if we have a line that way, this point where this line cuts the x-axis, that point definitely is x0, because the value of y here is 0. Along the x-axis, all coordinates along the x-axis, the value of y is 0. But there is a certain value of x. Okay? So the x-intercept is the point or the value of x at this point where this line cuts the x-axis. So if this line cuts the x-axis at, let's say, point, this is 1, this is 2, and this is 3. So assume this is point 3. So the x-intercept of this line is 3, because it is the value of x where this line is cutting the x-axis. So one thing that you need to know is that at the x-intercept, the y value is always 0, and that is the idea that we are going to use for this question. So at the x-intercept, the value of y is 0. So for this equation, we can replace, or we can substitute y with 0. So if we substitute y with 0, it's going to be negative half x plus 2. So we can take this negative half x to this other side, so that we have a half x is equal to 2. Okay, is equal to 2. So we can multiply through by 2 out of 1 by 2 out of 1, and x is going to be 4. So 4 is the x-intercept, or rather at that point where this line is cutting the x-axis, the value of x will be 4, and of course the value of y will be 0. So I believe we have understood that part of that question, and now we can move on to the final part of this equation, of this question, sorry. So the final part of this question. So the final part states that determine the point of intersection of line L1 and L2. Determine the point of intersection of line L1 and L2. So let me draw a simple Cartesian plane once again. So let's say we have, that is the Cartesian plane. So let's say these are the two lines. Okay, those are the two lines. They are intersecting at a certain point here. They are intersecting at a certain point. So what the question is saying is that we are supposed to get this coordinate of this point. Okay, that coordinate. So one thing that you are supposed to realize is that at a point of intersection, okay, this coordinate is being shared by these two lines. Okay, this coordinate is being shared by the two lines, and so this means that the value of y at this point for one line is the same as the value of y for the other line. Okay, and the same case for x. If this is point 3 and let's say this is 4, this point x or this point would be 3, 4, and it would be shared by these two lines. Okay, so I believe you're getting the idea. So what we are going to do for this example, we're going to say that, okay, we had the equations of these two lines. For line 1, the equation was y is equal to 2x minus 3. And for line 2, the equation was y is equal to negative a half x plus 2. So those were the two equations. So we are saying that y is equal to y. Y for this line is equal to y for this line. Okay? But what is y? What is y for line 1? Y is equal to 2x minus 3. So and for line 2, y is the same as negative a half x plus 2. So, and we are saying that y is equal to this other y. Okay, y for line 1 is the same as y for line 2. And y is equal to 2x minus 3 for line 1, and y is equal to negative a half x plus 2 for line 2. So this means that 2x minus 3 is the same as negative a half x plus 2. Okay, so we have an equation here that we can get the value of x. So let's try to work out the value of x for this equation. So we can move negative a half x to this other side so that it becomes 2x plus a half x is equal to, and then we can move this 3 to this other side so that it becomes 2 plus 3. So this will be 2 and a half 2.5 is the same as 5 out of 2x is equal to 5. And then we can multiply it by 2 over 5 by 2 over 5, so that x becomes, so this cancels and x becomes 2. So what is x? X is the coordinate of x at this point. Okay, so we have this point. We now know the coordinate of x is 2. So we need the coordinate of y. So how are we going to get the coordinate of y? We are going to go back to any one of these equations, either that one or that one, and then we substitute x with 2 to get y. So I'm going to substitute it in the first equation, that is y is equal to 2x minus 3. You can substitute it in any equation. Okay, so y is going to be 2 times 2, okay, x is 2, and then minus 3. So y is going to be 4 minus 3, which is 1. So the value of y at that point is 1. So we now have that point of intersection as 2, 1. As 2, 1. This point here, it is 2, 1. So I believe you have understood that question. We are going to leave it at that. In the next video, we shall continue with question number 19. So thank you so much for watching. And if this video is helpful to you, please consider subscribing to this channel for more updates in future. Goodbye.